Good evening. I think we'd like to get started now, so please take a seat. So welcome everyone. I'm Michael Pisani. I'm the Vice Chancellor for Research and Economic Development here, and I'm very pleased to be able to introduce Jack Dangermond, the CEO of ESRI. Jack is a landscape architect by training, and in 1969 he founded the Environmental Systems Research Institute with a vision that computer mapping and analysis could help us design a better future. Under his leadership, that vision has continued to this day, and ESRI is the world leader in GIS and geodesign, and they're used in every industry across the world and making a difference. ESRI employs over 2,700 people in the US, many who share his passion for GIS. Today he's going to be talking to us, but now I'm going to go off script. I met Jack first about 3 or 4 years ago, and he complained that UCR wasn't doing enough in spatial science and geospatial design. We thought it was a good idea not to, and so we've created a spatial science center and have recruited its first director, Serge Ray, who's in the first row. So Serge, welcome. We're actively recruiting 2 more faculty this year. And then one other personal note I'll tell you about Jack. He's the only CEO who I've heard mention the word Hadoop. Okay, so today Jack will be talking to us about creating our future, sustainable solutions for our world. Jack, thank you very much. Thank you.
Well, thank you very much for coming this afternoon. Do you have any questions first? I do much better. Or things that you want me to cover? Or why are you here? Yes.
Could you cover why students should learn GIS and mapping?
Okay, I'll do that. What else?
As a co-convener, I wanted to say that there have been many conferences on migrations in the past decade. The idea here was to understand it not just politically, but culturally and globally, and to bridge between histories of migration and the history and possible futures, with an emphasis on the power and the positive, the catalytic effects of migration.
Okay.
You serve 130 countries with your services, at least that many, perhaps more.
192. It's changed, you know, Pat. It's how long ago was it when we met?
Anyway, to relate this issue of migration to the work that you do with countries around the world and the impact upon your particular business and profession.
Mm-hmm. Okay. You want me to talk about that? Yes.
I just wanted to find out how far back in time did your program go? Did it go into antiquity?
You're a historian?
Yeah.
Okay. Good. Nothing else? Nothing about etymology? Okay.
How might we use the program to understand other forms of migration, such as infectious diseases?
Okay. Oh, that's a different dimension of migration. Okay. Anything else? Well, I thought what I would do is start by talking about ESRI. It is a company in Redlands. We have about 2,700 people there. We have about 10,000 employees around the world. And they are all about, you might simplify it by saying, applying geographic science. It actually had its origins just a few buildings away in the geography department when it was here. It was one of the finest geography departments in the world with specializations in earth science. It also had a large computer center that in 1969, in the middle of the night, would rent cycles to me. So I worked during the day, and then I'd work all night here in a basement across the mall. We have as a kind of mantra that we apply science using technology called GIS, and I'll explain what that is and what it means in a moment. So today we remain a private company. We are zero debt. We were a startup then. We never borrowed money. We never took venture capital. We stayed sort of off the grid with respect to a technology company. It continues to be strong and evolve through iterations of technology waves. At that time, it was the mainframe here. It was long years ago. Then we went to mini computers and workstations and PCs and then servers and then the web and then the cloud and like that, now with mobile devices. So our main focus has remained the same of science and engineering and its application to different kinds of work, and I'll explain that in a moment. We promote it like any normal business would, but we promote it in education circles, in science circles, and research circles. It's kind of our advocation. And the way we do it is by serving our users, which is kind of a philosophy that was born out of the early years in Redlands, where we gathered some of our customers together and we asked them what they would like us to do. And they offered to pay us if we did what we wanted, what they wanted us to do. And so we took them up on that. It's an odd way to do business, but we did it. And we gradually built a little product that became more and more popular with different releases or iterations. That's kind of our history. Today we have about 350,000 organizations. One of those is the EPA. One of those is FAO. One of those is the city of San Bernardino. One of those is city of New York and LA. Most cities in the world use our platform for maintaining their systems of record about all the stuff that they manage. They do it through transactional updates, just like you would update money. They use it for updating their geographic stuff, like streets or police incidents or trees or roads or buildings, all that kind of thing. And likewise, you can just glance through this. It's become a kind of quasi-standard within government to use our platform, which we never anticipated in the beginning. The reason why this happened, I think, is because it provides value. So it provides value in making things more efficient. It provides value in helping people make better decisions. It helps provide value in helping people communicate more effectively. It provides value in integrating science into the way people do things. These are the four main pillars. And I'll sort of start off by showing you some of that work. But before we do that, I'd like to back up and talk about the context of this conference, which is migration. And migration is one of the things that we can study, that we can see, which is challenging. And whether you look at it on the positive side or the negative side, it is a force that is co-evolving with many other things. And I suppose I'm being repetitive to other speakers that were earlier speaking, but totally wrapped up in population growth, climate change, scarcity of resources. All of these things are not by chance independent phenomena. They're co-evolving in a direction which suggests that the arrows are going in the wrong direction. You know, if you're into metrics, clearly the metrics are not good. So the evidence is, from my perspective, and I'd hate to be doom and gloom here, but the evidence is very clear that we got to make a radical change. And that's the context of your and my life. And for those of you who have children and grandchildren, I mean, it's doom and gloom, actually. We just need you need to just open up the goddamn newspaper every morning. It's on fire if you still read the newspaper. I mean, the news is on fire. Everything's on fire. And it's being driven by this notion of that we're consuming about 3.5 planets of resources today relative to what's sustainable. And whether it's E.O. Wilson said this or Paul Ehrlich said this or all the great scientists that are currently here make the data and evidence very clearly available, and it's just not sustainable. I mean, you guys know this, right? No matter how positive we try to be or how great we want America to be or any of that other stuff, these things are co-evolving, and for me, the way out of it is to first understand things and then build a strategy to act. That's actually been my whole life work, is to understand things and then try to figure out how we can connect that understanding to action. So my good friend Richard Saul Wurman, he's the guy who started TED. He has a little phrase he keeps hammering on me: understanding precedes action. So fundamental. He has a way of simplifying everything. So for me, if I look back on my life's work, but more importantly, our users' work, it's all about creating understanding, geographic understanding. So today, you and I are living in an amazing time, I mean, just transformational time, where virtually everything that moves and changes, maybe not at the insect level yet, but close, is being measured. And those measurements, whether they move or whether they just change, temperature, water flows, whatever it is being connected. The so-called Internet of Things. So we're wiring up the planet. And I see this in my work every day. It's pretty phenomenal. And it's accelerating enormously. Billions and billions of these little devices. And our customers are starting to say, we're going to make our city smart, or we're going to make our utilities smart by wiring everything up. So we'll have access to all that measurement. Are you guys tracking me on this? This is what really the big data revolution is about. And the way I play into that, and the way I see it, is that this field, GIS and mapping as a visualization of data, will incrementally become essential as a language for understanding. Understanding where the traffic is. You use that on your little Google thing. Understanding what the climate is. Well, you do that before vacations. Understanding where you should locate. Starbucks does that in all of their work. Understanding the migrations of the world. What's happening from Syria to Europe. What's happening from, the south to the north years ago in time. All those things that you've been talking about can be understood very clearly on a map. And the map, in a way, is kind of a booby prize. It's really the visualization of a database or data or analytics or models that can be rendered in a map form. And so I'm spending a lot of time at the beginning, forgive me for going so slow on this, but I really want you to get this notion that the notion of digital mapping and digital spatial analysis and digital information provides us through GIS a kind of context as well as way to see the content. And increasingly that's happening in real time. So, how many of you think GIS is a technology? Yeah, it's good. It is a technology. But it's also a framework and a process, or my friend Michael Goodchild says it's also a science, and I'll try to define that. It's the science of abstraction of geographic phenomena, cultural geography, migration geography, demographic geography, physical geography. It's the abstraction of geographic science into a computer. Data management and data integration is sort of step one. Then it's being able to visualize, a science of visualization, mapping, digital cartography, 3D rotating in real time. It's the science of that. It's also the science of spatial analysis, looking at how all these things are interrelated in space and time, modeling, the science of modeling and prediction. And then it's the science in the blue stuff of how you apply that science to planning and designing and decision making and finally actioning it into the field. So I think of my users as scientists, applied scientists, and they're measuring, analyzing, visualizing, deciding, and acting. And if we back away for a moment, which you guys have been talking about all day, see the context of migration, we can study it by measuring it, analyzing it, visualizing it, predicting it perhaps, predicting what's going to happen in reference to other phenomena that's all changing, and then hopefully take that into a positive direction of taking action. So I'll simply assert to you that this stuff that we've been playing with for years provides a framework and a process for enabling smart communities, but also smart regions, smart government, smart utilities, smart businesses, smart all of it. In other words, a platform for creating a more sustainable future in the future, because it drives on the buttons of understanding. Okay, I've said a lot. Do you guys have any questions so far? Well, let me show you some evidence. I like to call this, by the way, the science of where. Isn't that a cool name? It's not the science of geography. I gave up on geography because they closed geography departments down. But the science of spatial, the science of where, you know, that's pervasive. So they're not going to get that one yet. The science of where is both context and content. That's the thing I want you to notice as we go along. And our users, all these millions of people doing this work, are working on environmental monitoring and assessment, whether it's climate change or threatened species or the drought that was here in California. They're seeing it, they're analyzing it, they're modeling it. In the natural resources area, foresters are using it. Agricultural people are using it with precision agriculture to squeeze out a little bit more productivity out of their farms. And whether that's a whole country, like USDA does, or whether it's little itsy-bitsy farmers, they all use it. No, they don't all use it. The big ones use it, and the leaders use it, and the innovators use it. It's being used in developing energy resources. And look, I don't go to the right or go to the left. I like to go forward with science. So oil guys, solar guys, renewable, non-renewable, they all need the science of where. So that's what I really enjoy seeing my users. So all the biggest oil companies in the world, last week the president of PetroChina was here, and he's just trying to squeeze out more out of the petroleum resources in China, but he's also distributing his oil to the gas stations. He's importing 60% of his oil from other countries. He sees it all as a map. I love this guy. But also, Department of Energy is picking the right locations for solar collectors. What's the most suitable areas? And they're using the overlay of many factors. These little slides here in Massachusetts. So what buildings can we locate solar collectors on? So whether it's little itsy-bitsy things or whether it's big planning things, it doesn't really matter. Thousands of tax mapping, that's the way I would describe it to you, organizations, or internationally it's called cadastral organizations, maintain land parcels, and they transactionally maintain these systems of record. And they not only maintain the record, but they do all this interesting exotic mapping, visualization of patterns like valuation. They predict valuation, they predict change. And these examples show creating the future. These people are using geography as a foundation to do land use planning, new town planning, like that. On this slide, we see users from the transportation field. And the two on the lower bottom, UPS and the post office, are ones that I'm most excited about this year. UPS saved $400 million last year. That's really money. 400 here, 400 there, it adds up, changes the deficit. Because they route their trucks using the science of where. And squeezing out a little minute here and 5 minutes there. And the post office saved nearly $100 million last year in postal delivery because last year they embraced the science of where, which is computational geography. It's really using computational dimensions to leverage our scientific measurements. I wish I had that little map when I was coming here that they did in Alabama of parking time. I finally found a place thanks to the great work back here. But you get this idea that organizations are institutionally driving efficiency, making better decisions, and being able to communicate their stories to their coworkers in effective ways. And the way they're communicating, especially recently, is through citizen engagement, having open maps that tell stories and get citizens or customers to actually start participating in the geographic information, crowdsourcing, giving citizen feedback. I don't like that plan. I blah, 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 which drives, this is democracy. And utilities. Are you getting bored with these examples? They're just examples. Okay. Edison, Sempra, they manage, PG&E, one of the largest utilities in the world, do all their gas line and electrical line. Every time they make a change, they update that database, and then they route the trucks to it. When there's an explosion, they bring when there's an outage, whatever. So they're getting smart in what they're doing. And then businesses, these are just a few of our users, but picking the right location, market research about who's around locations, so I know what to put in the stores. So Walmart, Walgreens, Harley Davidson, Starbucks, McDonald's, all these companies, a lot of the little guys don't have it yet. There's something one of my colleagues and I are working on, being able to empower over the web so that they can get the geographic advantage. And that's a sort of a rude way of saying it. Big guys, they can spend the money to get the geographic advantage, but little guys, we're trying to democratize little guys getting it through web mapping and web analytics. It's really exploding our field, actually. These are some examples. Somebody mentioned Ebola, healthcare. The examples up in the upper left showed, the patterns of what was happening with Ebola when it was very active and spreading. I say geography helped them get it in a box. They set up quarantine areas, migration areas, and there's a lot of users now that are doing this with Zika virus, predicting when the climate changes, what it's going to go after. And these are little local governments that are within the red zones. And Loma Linda here is tracking hospital readmissions. That's part of the Obamacare legislation, that they don't get rewarded based on transactions. They get rewarded on results, which is really a great thing that they did. And that's happening across the world through WHO and the different hierarchies of medical care. I would say geography is helping the world be a safer place by tracking crime. Where are the hot spots? Where are the bad guys? How can we dispatch more effectively? And I put this one in the center in the top. This is those little brown dots on the migrant rescue are all the boats that leave North Africa every day. And a lot of them don't make it. So this is a command and control tracking system that's run by the European government to watch the migrants, and they watch them blink out, and then they send in emergency vehicles and try to do their best, and they usually take them back to North Africa. They're not really dealing with the cause of the migration. They're dealing with the tactical response to trying to save lives. And it's used heavily in supporting peacekeeping. So in the United States, I'm very proud to say that our intel organizations are using it to catch bad guys. And they do a good job. They tracked, they caught, they targeted Osama bin Laden. They used the science of where to figure it all out. And they do that every day. The military uses it extensively in conflict analysis. But the flip of that is that organizations like the Institute of Peace are using it to try to figure out the geography that might be ready to explode, and then what are the treatments. And a story here was in Israel very recently, last year I guess it was, where, I better not go into that, is just they stopped a lot of conflict between the Palestinians and the Israelis by just adjusting geographies. Okay, I'll just tell it. The police departments in Palestine were restricted for going into certain areas by the Israeli Defense Department, IOD. And they didn't really know what they were doing, but they carelessly restricted the Palestinian police from going into all the places where there was drugs or prostitution or other weird stuff going on, bad neighborhoods in Palestine. As a result, they were unpoliced. And so the guy from the Institute of Peace brought the maps over to show what was going on, and the Israeli defense said, no, that can't possibly be. No, we don't even have that restriction. But the maps showed the evidence, and they started to, okay, let's start to agree. Now, Palestinian police cover the areas, all of Palestine, not just the areas where they're peaceful. It's a story, actually, they won't even tell it. But when I saw it, it was so cool. That's happening by the UN. It's this notion of the maps provide a platform for negotiation. The Bosnia Accord, peace talks that were all facilitated by GIS-based maps. So the president sees maps every morning, 7:30. He turns out to like maps. Mr. Obama loved maps. He used them as a framework for lots of his decision making. He was briefed, understood it, reacted. So humanitarian missions use maps for economic development, to see social violence so that they could understand the patterns, ethnic cleansing, and then react, both at the policy level and also real action. Is this still interesting to you? So what I guess, showing you is evidence, not exactly in migration, well, some of it's migration, showing you the evidence that a platform for understanding migration might be data and patterns and space-time analytics and visualization of migration. And it may also be the platform for action, if there's action to be taken. And some of that action is related to not the migration itself. It's like those guys going across the Mediterranean. You're dealing with the symptom, you're not dealing with the causes. So how do you understand the causes? By overlaying geographic data of various types. That's how. You still may not be able to act, but the science of where provides the framework. And this is the WRI. They're looking at clean water around the world. World Vision is using it as a basic platform for action, particularly in Africa. This one is CIGAR and Harvest Choice Initiative, where they're modeling areas where certain kinds of food would grow that are not necessarily native. My friends in, don't bring any non-native species. Okay, well, yeah, but people have to have food. So introducing stuff from South America into Africa in the same climate types is revolutionizing food production, and CIGAR is a leader in this, using GIS as the framework for doing it. These are all about the big job of tracking and analyzing climate change and its impacts. I realize in this administration it's becoming less popular, but somebody's going to have to talk about it, because the evidence is very clear that it isn't just about climate change or the cause of climate change. Who cares? We've got to figure out resiliency plans so that, in fact, migration doesn't. You talk about migration. We did a model in Miami Beach for the city. There's going to be mass migration in the next 50 years out of Miami Beach, unless they build a wall or something, So they have an issue of either green infrastructure or gray infrastructure solutions for, the water. You raise a meter, which is the conservative in 50 years. What are you going to do in Miami Beach? If you've ever been there, it's not good. So, all right. So at the global scale, the UN has some of you know about them, 17 Sustainable Development Goals. And you know these?
No.
So the UN, you don't really? This is amazing. It's okay. I'm not trying to make fun of you. Most people actually don't know them. But over the last couple of years, the UN has formulated and is now promoting the idea of 17 goals that they're getting. I think they've got 150 nations together to agree on that these are the goals to reduce poverty, to reduce hunger, health, quality education. These are kind of like goals, right? You got the idea? And by each country, they said, let's start measuring each of these goals. So they've come up with 192 indicators of progress in poverty, in clean air, and water purity, et cetera. And there's a consortium now emerging in the statistics branch of the UN that is organizing each country to set up measures in each country. So you can see on the left, it's about the zero hunger work going on in Kenya. And those statistics can be spatially aggregated into a map of the world. The one on the right is gender equality. You can sort of see the variation of gender equality. So you agree on these 17 goals. They break down into 192 indicators. And each of these 150 countries said, we're going to start measuring these by subnational areas in our country. So this is actually a web system that we're building for the UN that'll organize the cultural and environmental geography for the planet. And its purpose is to not only share to the secretary what's going on, but also to share to the public. Isn't that cool? So we'd all understand year by year the progress, or is the arrow going in the right direction or the wrong direction? It starts by measuring. If you can't make progress unless you set up some kind of measurement system. And this came really out of work that was done in the city of Baltimore with something called City Stat by Mayor O'Malley. Then he did it at the state level. You might have run across this character. He ran for president against Hillary. He set up State Stat in Maryland, and he measured all kinds of indicators and made it all available to the citizens. And as a result, turned out during his 8-year term there, they in Baltimore, he dramatically reduced crime, because they were measuring and putting the cops where the action was, not where the rich people lived or like that. At the state level, he cleaned up water in Chesapeake Bay by getting everybody involved, because he made it all available as information. He showed grade score averages in all the schools. As a result, they started targeting the schools where they had the problems, and everybody bought into it. So it's kind of the story of you create understanding and then people activate when they see it. One of our problems is on the globe, we don't even know. We certainly don't know in the oceans, and we know less in developing worlds and we don't have a global accounting system that we can actually understand what's going on. I mean, you have to accept what scientists say. This is sort of taking all the measurements and putting it together into a platform. So I'm sounding a little bit evangelistic, I suppose. But I'm so excited about this project because I think it's going to make a difference. So I guess I'm talking about all the work that our users do. One of the new inventions that one of my colleagues is going to show you in just a moment is called story maps. These are a new invention where you can make a map on your laptop, and you can do it either with a simple map or a complex map, and you can publish it on the web. So today, we made about 40 or 50 million story maps. Today. It's not Facebook, but it's trending, upwards. And
Use of story maps.
Use of story maps, right. Actually, new story maps, 500 today. And there are maybe 250,000, would you say? Yeah, they keep adding. Kids are doing it, agencies are doing it, NGOs are doing it. I don't know if this is true anymore, but last year the president looked at all of his daily briefs through story maps, so I suspect it continues. So, and these story maps are interesting because they're not just a document, they're wired to data that's changing all the time. So if you move around and pan and zoom and something changes, in the database, like, you know, the satellites, the weather has changed. The story map is different. It's really very exciting. So this is a new medium that's emerging, leveraging the GIS databases. But you guys don't really know yet what a GIS is, so I apologize. I'm doing this whole lecture backwards. I'll start now telling you what a GIS is. It's a system for managing geographic stuff. And whether it's a bug or an ant or an animal like an elephant moving, or a person or a geologic unit or a pipeline or an electrical light or a whole city, people basically they abstract what's out there into a database, and then they update it like you would with barcoding on a grocery store, or you bring in real-time measurements like sensor networks on a map, or you take pictures like from satellites. These are the kind of sources that go into these databases, and then you can use it for mapping or planning or reporting, like a dashboard reporting. What's the status of one of those 17 goals, or what's the status of Hurricane Sandy right now, or what's the status of outage in Southern California Edison, or what's the status of where my vehicles are. That's kind of a reporting and monitoring system, like these big dashboards. So, yeah. Any questions about this notion? We used to do this all on a mainframe, so you'd build a big mainframe database and you'd put in some cards and it would update it once a day, and then you could make a map once a day. Now, increasingly, this is all real time. You got real-time data coming in, and the way that you look at these maps are through, you know, the devices that most of you have. Like your Google map, you all know what a Google map is. It's exactly like that, except that instead of just a simple, cartoon thing, it's all the geographic richness of GIS. So what's occurring in this field is, well, a lot of people do this as individuals. You know, they're a scientist, they collect their little data collections and they make their maps, or they're a planner, they make their maps. But those are starting to get connected to enterprise systems. Like I would assert that the whole UCR should have an enterprise system where everybody connects and shares their data that can be mashed up and overlaid and analyzed together. That'd be really cool. And there are some spatial universities that are starting to do this. My old alma mater, Harvard, is starting to do this. The different departments are breaking down the barriers by using spatial location as a framework for bringing things together. They don't have geography there either. And this remarkable thing is happening over on the right, which is different institutions that have their geographic data in their little databases are starting to serve it out to other institutions. Like I can bring in the county of Los Angeles parcel map, and I can overlay on top of it, let's say, the electrical lines from Edison. So Edison doesn't have to maintain their base map anymore. They can just use the counties. Electronically, it's just brought in. You get this idea? I'm going to come back to this idea because this is really neat. So my hundreds of thousands of users are all starting to share their information. They're starting to serve their information map by map. Some people are making base maps, some people are making images, some people are showing where the dead cats are, somebody's showing, where the crime problems are, somebody's showing where the bombs are going off, somebody's showing like that. They're starting to share their layers. And I can go to this repository and bring those layers together and mash them up. I don't have to author all the data. I don't have to collect all the data. I don't have to put all the data in my database. I can just sort of bring it in. So I like to call that a kind of nervous system of the planet. And as these guys all wire up the real-time measurements and also their operational data and share it, they're going to be building this amazing infrastructure of geographic data and using each other's data. Okay, you're not very excited about that, I can tell. Too bad, because That's not just a vision by Jack. My sense is like the internet, this is now going to just keep going along.
Really critical in two dozen or so nations around the world where there's conflict.
Yes,
And people just can't work together.
right. I don't understand that. I mean, a lot of the basis for conflict is lack of understanding. You just don't understand. I don't have any food here. You just don't understand. You know, Mike, 700 years ago, the border was here. The conflict between India and China consistently has been semi at war, you know? And you get the right context laid down, like between the Israelis and Palestinians, and I saw a lot of the conflict disappear. So I'm not saying that this is the answer, and believe me, be as skeptical as you want. I'm simply saying this is one of those little things that can give us some glimmer of hope, because for God's sakes, that's what we need in this world, is understanding. So what is driving now this technology? It's getting smarter. All these technologies are being integrated into GIS as it evolves along. So you think about GIS is release 23, release 24, release 25, so it keeps getting smarter. It's now on mobile devices. It's now in the cloud. It's now distributed, those kind of things I've been talking about. And it's also real time. So I mentioned the IoT is wiring everything up. All devices with real-time data spatialized can drop right into that frame. And people like FEMA this is Hurricane Sandy at FEMA. That's the dashboard at FEMA. And they're tracking all the different kinds of layers in from the different agencies, state, local. So Sandy was a revolution compared to, you know, Katrina, because everybody saw in a common operating picture what was going on. And states shared with FEMA. City of New York shared with FEMA. FEMA shared with City of New York. And they overlaid each other's maps. The utility company, Con Ed, shared what's out and what's not. The gas companies shared where there's gasoline. They started operating on a common context, and they avoided what happened. I mean, Sandy was much worse than Katrina, but didn't have the same effect because there was collaboration at the social government level that we've never seen before. So GIS is enabling the integration of IoT into, this is the Seattle Police Department. They now look at real-time crime as it's happening. Transactions, web, maps. You know, just imagine what happens when you do that. Same thing happened with Ebola. There was real-time observational data going to the cloud. WHO was able to see what was going on, lay out strategy. So organizations, my assertion, will move at the speed of light using geography as a common frame. Things are going to speed up a lot. This smart GIS concept connects everybody. So everybody has an identity, just like you do on social media. I'm connected. That gives me privileges to be able to look at some data and not look at some other data. Makes sense, doesn't it? And also collaborate. I draw a little sketch on my map and I email it over to you, or I chat it over to you, and somebody else sees what's going on here in real time. And GIS provides smart analytics, visualization analytics, and big data analytics. For example, being able to do things like we do in business intelligence tools, drag and drop data onto a screen and see it, spatialize, and then I can interact with it. Later I can show you this stuff live if you want to. So in a browser, I can access data about India, start to do social analysis or demographic analysis related to this, related to that. And in terms of big data analytics, I can take very, very large data sets. Like, these are examples, they're not quite relevant for you, but the bottom one is picking the right location for solar collectors. The little orange map shows the place in America that's best. And this was done by overlaying other variables, like map overlays, like plastic overlays, and modeling it. And You might say, well, that's a simple little map. This is 40 billion pixels of geographic data overlaid in a few minutes. Well, we've never been able to accomplish that. I mean, we couldn't even think of it. And these are analytics of all the lightning strikes in the last 10 years. So looking at space-time analytics, I can see patterns and predict where lightning probably will strike or has a higher probability. Well, okay, start to think about migration. What's the probability that something's going to happen here that might stimulate migration, which will then have impact on social services in Central Europe, which will have impact on economies, which will have on politics, and blah, 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 blah. Geography is a common frame. This technology is also revolutionizing how we plan. I can, off the internet, bring in different maps, overlay them, sketch out alternatives. This is Singapore in a 3D development that somebody is planning out, and it's overlaid against lots of layers that show the impact on water, on sewer, on traffic of that particular development. Did I have to collect all the data? No. I can, as a very lightweight designer now, look at alternatives for urbanization or farming or green infrastructure or strategies for mitigating migration. This is an example in Los Angeles of something where we're trying to extend the city's GIS to the community, trying to get all the people in the community to participate in the city's future. So we're taking the geographic data, put it in the cloud, and then letting the Mayor Garcetti in this case, say I want to address this initiative like traffic deaths at pedestrian crossings, or open data, or crowdsourcing, or where do we locate homeless people, et cetera. So this is a kind of a platform for connecting communities through mapping. We're running out of time?
7 more minutes.
7 more minutes, okay. I'll speed it up. And this idea of a hub, taking all the city's data and making it available to startups, for citizens, for others to be able to play with, is, I think, the next generation of a well-run government. Because governments in the future, governments even now, like Pat San Bernardino, don't have enough staff. But if we got everybody engaged at some level, or some people engaged, and actually participating in initiatives, collecting data, and addressing some of those core initiative issues, that's what Mayor Garcetti has pioneered. And now we have 23 other cities that are going to copy LA and roll it out this year. So what I've been talking about is a smart GIS integrates a lot of things. It integrates systems of record keeping. It integrates systems of engagement like you have with social media, your name, your identity, with systems of insight, analytics. So let you pause for a minute on this. Most organizations have systems of record, these layers. But what this brings together is everybody gets connected through their identity. They can have access or privileges to get the data with other people that can do analytics on it and share the analytics. So bringing different segments of an organization, but also segments of a city, segments of society together on a common abstracted, easy to understand framework. I'll close by just a couple of showcase technology stories. GIS is, what we build in Redlands over there is technology that runs on desktops, on devices, and in servers up in the cloud. And they're all connected. Just sort of like when you buy an iPhone, did you know that you get the iCloud with it? And it has iMusic, and it has, so somebody buys one piece and it has a much larger connected piece. So inside of organizations, what's occurring is lots of different players are taking these devices and beginning to collaborate and share. That's kind of the mantra. And what do? They make smart maps, they make 3D visualizations, they spin a globe, they look now with virtual reality screens at this information, they walk in the virtual world. They also do analytics. These are just a few new ones. They look at spatial statistical relationships. these are a dozen of 1,000 different tools. They also can access other people's data. People are now sharing their maps in the cloud, and you can use my data, I'll use your data. And so in this platform, we make about 2 billion maps a day. That's a lot of maps, actually. But these are maps not for citizens so much, they're maps for the enterprise. So we're starting to see smarter approaches to these things like planning and management of our world. But it's still very segmented. I don't want to go too far on this, but I think, my sense is that this might be something that's very powerful for our future. So we'll continue to advance these tools, and I'll just simply close by saying humans have never been more capable of actually sharing and using geographic knowledge and also getting an understanding and acting. I just say that we've never had that before. We could only dream of what's emerging. And it's only, 2017. It's all exponentiating at all the different levels of technology and science. So my assertion, again, as a positive note for you is now is the time for us to begin to embrace these big challenges, not to turn our backs on them. Now is the time to envision what we possibly could do as solutions to all those big challenges. How do we deal with population exponentiating? It's not sustainable. All the laws of biology, you can't do that. At a certain level, you run out, and we are running out at this point. We're leveraging everything we have. So we got to really take all of our best scientific knowledge, all of our best science, all of our best technology, all of our best design thinking, our creative thinking. We got to be all in on this, and learn how to create, learn how to make polarized positions work again. To pick on something that's always in the news these days, we need to teach everybody how to think about the principles of design and planning, and get on with it. So that's a conclusion to what I really wanted to talk about is, can we use this element? And I'm not saying this is the answer to all problems, but can we leverage this kind of element to create a better future? That's the question I'll leave with you. All right, thanks.